at some point we have to be okay with when I start the recording, you'll be able to see yourself for a moment and not react to that. That would be great because that's that mature 7th grade behavior I'm looking for. But so especially when I like leave a message like this, like we have a lot to get to today. But like, anyone in here ever done yoga? Like, yeah, or did you do it with Mrs. Coleman? Okay, so if you felt like what it feels like to actually be like mindful of what you're doing and just doing like one thing, like that's kind of what we want when you come into classrooms is like, okay, now we're just doing math, right? Whatever else has happened this morning, like leave it at the door. We got a lot of math to do. Right, so today we're continuing on from what we talked about yesterday, but first we're going to check 211. So please, if you don't have 211 out, like guys, I typed this stuff up to make my life easier and make your life easier. We need 211 out to check it, and we're going to do that right now. So that I know it was a longer homework we started in class, and it's okay if you're not done with it, but I want to review it for those of you that did work on it and want to check some of those answers.
I didn't really understand
211. Let's, when we get down to it, let's chat about it then. So let's check 2/8 and 2/9. 10 tenths makes a whole. 100 hundredths makes a whole. It asked how many tenths in a whole, how many hundredths in a whole, which 10 tenths, 100 hundredths, 8 eighths, 12 twelfths, like whatever the denominator is. 210, another figure out the missing part of the circle. What would your common denominator be for 8 and 3? 24. That's the easy one because you're just multiplying together. So actually, and it doesn't look perfect with this zoom, but in C it felt like there's approximately 50%. Not perfect, right? So this is actually a tiny bit over 50%. So that's why this line isn't quite straight because it's just over a half. So hopefully you got 13/24, but then I think it's at approximate it into a percent. In 211, let me steal a screen over here and double check what the question was. Oh, so a lot of people thought this was like a trick question, and it's not. So in 211, it says Nicole's machine that will produce a number between 1. Okay, so this was a typo from me. If you weren't around at extensions to hear my announcements, the page that I gave you was missing this 1 through 50, which this problem wouldn't make any sense if you didn't have those numbers, so my apologies. Guys, I am human. This is my first year making all these worksheets for you. It's like my 3rd or something year through CPM. I don't know why I didn't make worksheets sooner, but I'm glad I'm doing it now. But you got to bear with me, right? So if you think there's a typo, please just come tell me. Now, I can't fix that all of you have that typo on your paper, but for next year, I got it fixed now, right, in my file. So multiple of 10. Multiples of 10 are like 10, 20, 30, 40, 50, like 10 times anything. Right? Any integer, we call those clean multiples of 10. Every number's not 100. So that's why that probability is an entire 1, a whole, that's like 100%. Not a multiple of 4. If I was you, I would list out the multiples of 4 and see how many there are before I get to 50. Right? I believe there's 12, which is how we get 38/50ths. And then 1-digit number, there are 9 1-digit numbers, right? Because they don't have 0, they start with 1. Does that make more sense, Ray?
Yeah.
Especially since we're missing those numbers. Also, numbers that we're missing, in 12, if you look at that one, if you weren't around at extensions after we had figured this out, you were missing the numbers 14 and 24 on your blue sheet. My apologies. I will tell you any day of the week, I am not above making mistakes. And yesterday morning, I was working fast, juggling a lot of things. I knew we had a couple teachers out, but I didn't think we were going to have half of our teaching team out, so that was a little stressful yesterday. All right, so let's keep checking the... Sorry, any questions at this point? Because I just scrolled down on the page, but not on the answers. So if you had those numbers, 14 and 24 in 212, you could have gotten 7 and 18. Remember with problems like 13, you can abbreviate and just put T or E, which I think a lot of you did on the homeworks that I was looking through and checked for you guys. Sorry, and there you could abbreviate to like REP for repeats, or like TER for terminates. Sorry, I was thinking back to theoretical experimental for T and E. Remember that mean? I had a few people come up and ask me this. Mean is average. Mean is the average, so we add up all the numbers that we have and divide by how many we have. Median is the middle when we put them in order. No, I will not start putting your numbers in order for you. That is a skill that you need to practice. I just copied the order out of what the book has, so in case you're doing your homework off the ebook or whatever. 15. Hopefully you got to those percentages. That's where some people thought it was a trick question. There's no orange marbles, so there's no chance of orange. We need to accept that there are situations that have 100% probability and situations that have 0% probability. Right? What are the odds I sprout wings and fly home? Like, that's a 0% chance. Red Bull is, might be, actually, I don't drink Red Bull because my heart issues. But, Red Bull might have those commercials, but it's not going to happen to us. So I got to turn on a little bit more light because we got to learn to check those problems. Those diamond problems, I hope we get to a point that I don't need to put the key on there. I forget if I even put it on this one or not. Yeah, I don't think I did. We talked about them in class, but those diamonds will always work the same. So it's always product in the top, sum in the bottom. And I had a student in a past year like, why do we do so many of these? That skill of being able to say 3 and 4 add up to 7 but multiply to 12 and work that backwards. If you look at 12 and 7, being able to figure out, 3 and 4 and get that quickly, that's huge in the class I teach to those 8th graders. That is high school math 2, sophomore level math, like second year of high school. That's a huge skill. That is important in that class. We want to match factors and parts of the sum. Big skill there. And then 17, 12 over 11, 17 over 5, 34 over 15. We love improper fractions. Improper fractions are better than mixed numbers most of the time. Well, and that's really an opinion of mine. Any other questions from that homework? Sorry, then I can actually close my internet screen. We can just move on. All right, so we should all have graph paper out. Should all have graph paper out. In your homework, you will also see a decent amount of those portions webs. There's a really nice math box, like math notes box, in chapter 2. I forget exactly what section it is. It might actually be this one, like tonight's. So if you already grabbed tonight's blue sheet, you don't need to look at it right now. But on the back of it, because that's just where it fit better, I put all the conversions, fraction, decimal, percent, so like the walkthrough of how do we do those things. That's what we're doing in the portions webs, is just converting fractions, decimals, percents, and we're being asked to write it out in words. So like 3 out of 5 or things like that. All right, so we need to remember the things we talked about yesterday with what makes things repeat and what makes things terminate. And we looked at some really, really cool number patterns, but now we're just going to try to clean up some rules. And some of you may have seen this on your homework with how many 9s do I have in the bottom in the denominator, and what does that turn into? So 218, if you want to go ahead and number this in your notes, please. And guys, I shouldn't really see blue sheets out. I mean, they can be under your graph paper. But please make sure we're not trying to do the homework during the class. You will miss learning. So go ahead and write down those 4 portions that we see here. And we're not going to make webs. And I started this habit last year because my students are getting frustrated at trying to draw the webs and taking up space, whatever. But you have the webs on your homework papers. So obviously just fill in the webs off to the side or write the text off to the side. But what we're going to do in class together is just random card through saying how we say this properly and then writing it as whatever we're missing, right? So we have the fraction here. So Sarah, how do we say that fraction properly? Remember, you guys can always pass. Can you see that from back there? Just making sure. Okay. Because middle school is when my eyes are changing a bunch. Bella? 7/10. Now we could say 7 out of 10. Anyone know why 7/10 is better to say as we go to try to convert things, Eric?
Because it's the separation of the one common into tenths, which is section of 10, and it's just 7 of the tenths. that are separated out of one.
Yeah, that definitely, but also it tells us exactly what our decimal should look like, right? Because we have the tenths place is our first decimal place. So please put in here equal to 7/10. And then the thing we haven't done a bunch of practice with, but we want to do more, is getting it to that percent. Go ahead and flip, if you have your blue sheet for tonight out, and you don't have to stress getting it out if you don't still have it out. But if you look on the back where it says decimal to percent, it tells you kind of like the trick way of getting there. I think it's bottom left. No, I'm wrong. Well, yeah, bottom left, but it's the top one. What do we do? What do we do with the decimal? Yeah, Meredith?
Multiply the decimal by 100.
Yeah, just multiply by 100, which if we want to talk about really just the trick, we just move it 2 places and it becomes 70%. So please make sure you have all 3 of those representations, the fraction, the decimal, and the percent. I'm not as stressed out about you writing the words, as long as we could say it out loud, either 7 out of 10 or 7/10. So go ahead and take a moment with B, C, and D. Whatever they're missing, go ahead and write the other ones on, well, write the original, then write the other ones on your paper. So for B, we should be writing down right now 0.75, and I said it kind of the wrong way, but that's one way you could say it, 0.75. There's a better way. Take a couple minutes, convert those, and then I'm going to pass out some papers while you guys do that.
You want to do all of them?
Yeah, if you can. Do them first on your own, then we'll chat with each other and double check things. And that's just for like any class. Do what? Yeah, do all of them. Yep, do all of them. Pretty much everybody, like I've talked to you, if you have any grade other than a check or a check minus. I have found time and I have talked with you. How are we doing? How much more time do you think we need? 2 seconds. Are you done? Yes, these are, well, not the most recent set. So the most recent set is not yet in that. Are we ready to talk about a couple of these? Because all that, I'm not super stressed about getting that homework back to you. I just want to get rid of it. Go ahead and chat with each other. Double check with your partners.
I prefer fun size.
Any volunteers we'll take first for B before I just straight call people and I don't know where my pen went. I have lost it. Mirabelle, what do you think? Or how do we say it better? Do you know that first? Okay, well give me whatever you got. Ooh, there it is. 75 hundredths. So saying that is better. Why? Yeah, and it tells me how the fraction looks. So guys, if you can say it properly, it tells you both the fraction and the decimal. Do you know the percent?
Yeah, 75%.
Absolutely. 75%. First thing we should all be able to write pretty easily is the fraction that goes with this, but then I need somebody to tell me what we do with that, all right?
Okay, so you need to convert it into the denominator with 10 at the bottom. So you just multiply it by 2, and then it will be 6 and 10.
We make it into a denominator that is a factor of 10. We could use 10 or 100 or 1,000 or any of those. And then you want to keep going?
And then it will be 0.6, and then it will be 60%.
Any questions on 3/5, how we work through that? Oh, I'm going to do some more random cards because I try to make sure I do that. Callie, D's harder. So as always, you can pass, but can you tell me what we could try to do with D? So when you said you were able to, do you mean like you used the calculator, or how'd you do that? Yeah, I'm okay with that, unless we say you can't. So you did the division to get the decimal value, and you said you got what? And something that you could plant in your memory right now, 1/8 is half of a quarter, right? Literally like half of 25 cents. It is 0.125. So every eighth is worth 0.125. So this is over a half by 1/8, which is how we get to 0.625. You want to keep going? Tally? Or no? No? Lydia, do you want to jump in? No? This one's tougher. Nick?
Oh, yeah.
We got fraction, we got decimal.
So then for the percent, I think it's 62.5%.
Absolutely. We multiply by 100, which shifts the decimal twice. It is 62.5%. I don't like people just memorizing a trick because that's really effective if you can get your brain to remember it's 2 spaces, 2 decimal places, and then you just have to realize which way, like left or right. Going from decimal to percent, we go to the right. And guys, give me your attention for a second. My brain works in a weird way, and we don't need to go into that. But to go from the letter D in the alphabet to the letter P in the alphabet, we'd have to go to the right. Our decimal moves right. To go from the letter P back to the letter D, we'd be going left. This decimal would go left to go from percent back to decimal form. If that works for you, that's like what my brain ends up figuring out is like, oh, okay, well now I can remember it because I've made some sort of memory trick. All right?
For the fraction, it would just be 625.
Yeah, we already have a fraction, but already I said we could also use 625 thousandths based off what we see right there. Any questions on any of these? Because we're going to jump back to the repeating, because none of these were repeating. Oh, not quite yet. I'm one slide ahead of myself. So use your skills to convert all these into fractions and percents. We should be getting faster. Now, I don't love just like rote activities of like, hey, try this thing a few times, but it is beneficial, right, for us to get used to it and comfortable. And it will let me pass out a few more papers. Yeah, both. Try to do the fraction. Now the fraction, if you can figure out what decimal place it ends in, because all of these are decimal into the other ones, it should like be a little bit easier than those that we just did being like 4 different forms. You know what I mean? Remember, if everything is good, I just put 1 grade on the front. If I need to put specific feedback, I do that in the pages. So if you have a check or a check plus, you probably don't have other feedback. I will make notes if I notice something you're like way out in left field on. But I mainly do that on masteries because I don't want your practice to be like high stress. So I have a bunch more to pass out, but we're going to start talking about a couple of these just to make sure you're comfortable with what we're doing. So when I talked about identifying the decimal place, right? Lily, can you talk to how that can help us convert all of these to fractions really fast?
Well, like, so for the first one, it would be 19 hundredths because, and then that tells you, like, what your denominator is.
Yeah. If we look for all that match, dude, that's the only one in the hundredths. But then I see 3 decimal places here, 3 decimal places, 3 decimal places, 3 decimal places. All of them with 3 decimal places will all be over 1,000. So this will be 391 over 1,000. This will just be 1. That's a bad one.
I'm not even sure what to call that.
A bad one. 1 over 1,000. 524 over 1,000. So that's not our real key skill on this slide. We want to make sure that we put some percent values also. But before we get to that, what's this going to be? 3/10, right? Or 3100ths, or 301,000ths, or we could keep doing it. All right. So we said on the last slide, we just multiply by 100 or shift the decimal 2 places. So we'll just go class answers. What's our percent here? 19%. What's our percent here? 39.1%. Not 1%. Yeah, it's 0.1%. Because guys, check it out. If I move 1 place, 2 places, I'm still in front of the 1, so it's 0.1%. You gotta have that percent sign, or else you're speaking in decimal. Down here, be careful. Well, there are different math languages. 1.9%. Thank you, Zach. I was wondering if anybody was still with me. I think people got stuck on me saying something about language. Here, 30. And guys, exactly as Eric was talking about, you can add zeros all day long if you want to. So when I go to move my decimal 2 places, you can throw a 0 on the end there and make it easier to see.
52.4.
There we go, 52.4. Are we all comfortable, or I should more so ask, are there any remaining questions on terminating decimal conversions? Because all of these terminate, none of them repeat. All right, so, yeah, Morgan. Yes, because when we start writing a bunch of math, to just put point whatever, it's easy to miss that you put a decimal point. You know what I mean? So when a number starts with 0, that's unnecessary. So I agree with you, Morgan. It's not necessary. The number's the same if I just write down 0.19. It's the same number. But for me reading your math and anybody else reading your math, you need the 0. Now, if you're just doing work for you, you can do whatever you want. But if I'm checking it, and like especially because I have a lot to check and go quickly, make sure you put the 0 so that I see the decimal, please. That's just like personal request. So Jerome works at a fraction factory, which is one of those lame CPM setups, right? Because that doesn't actually exist. But he received an order to write 0.73 as a fraction, and he knows he can't use 73 over 100 because that terminates, right? And this doesn't, the 0.73. So let's remind ourselves, let's write down on our paper, 0.73 with the repetend means 0.737373. It's going to repeat those 2 numbers over and over again. You with me? Writing this down?
Oh, yes, I am.
So he's a calculator on Google?
So he what?
So is he the calculator on Google?
Sure. That is the fraction factory. Ah, thank you. I was waiting to see if anyone was... Unless we keep writing 7373, we either need the repetend or the ... But the repetend is better because it groups the numbers that are repeating. It doesn't just say this pattern keeps going, which is what the ... says, is this thing keeps going. It's kind of less specific. Can anyone remember from either a lesson yesterday or maybe what you did on your homework, how we convert a repeating decimal into a fraction? And there's kind of like a little trick that goes with it. Bella? You're trying too hard. It's actually easier than that. What you're saying might be right, but I don't necessarily want to go down that path because it's the path of more effort. Right? We want the path of least resistance, least effort. Right? Yeah, now how do you know what goes on the bottom, Araya? Like, yesterday we worked with nines, right? Like 1 9, 2 9s. It was just 9 on the bottom. Why'd you say it's 99? You're right, but why? Glad you said that. For the love of all things math, why? Why does this happen? I never understood this. True confession, I never understood this till I was a teacher. And I want you guys to understand why this happens. Right? So Jerome is like, okay, fine. Araya told me the right answer, but I don't know why.
Why?
So he's looking at this saying, well, okay, if I start to just play with the numbers, 0.73 repeating, if I took it away from itself, well, okay, that's not really helpful. Right? 0 equals 0. Great. If I multiply by 10, I could get a different number repeating. You don't need to be writing anything down right now, but I would like you focused up here. I got some people doodling. And then he has this epiphany. You know what an epiphany is? It's like a big, like when the light bulb turns on. Yeah, exactly. So Lily, when the light bulb turns on. So this doesn't work out nicely because now the repeating is 3 7 instead of 7 3. And if I try to do this subtraction, where do I even start? Right? Because these keep going, I can't really figure out where to start. But he realizes if I multiply one of these numbers by 100, that shifts 2 decimal places and lines up 7 with 7, 3 with 3. And now, does it matter where we start subtracting? No, because I know every single decimal location lines up with itself. Are we with me just to that point? He multiplied by 100, got a 2 decimal shift, and lined up his values. Yeah. Any questions? So now, we'll come back and take a moment for you to write it. I just want you guys kind of absorbing right now. Now he says, okay, 100 of that repeating thing minus 1 of them leaves me with 99 of them, right? He took 100 of those repeating things. It doesn't even really matter what is repeating. Subtracted 1 of them, and now has 99 of the repeating things left.
So 1 minus.
You with me still? He took away 1, and that equals the nice number of 73. And a branch of math that we're going to do more and more with this year is algebra, where one reason I love algebra is you can do whatever you want. You can essentially do whatever you want, as long as you follow just a couple rules. And one of those rules is if I divide on one side, I've got to divide on the other. So if I want to get rid of that 99, I can just divide by it. Right? Divide by 99. What's a number divided by itself? 1. Ooh, not that subtracted by itself is 0. Divided by itself is 1. If I divide by 99 over there, I divide by 99 over here, and we now see 0.73 with the repetend, right? That's on the left-hand side, equals 73 over 99. The reason that the number of 9s on the denominator are the same amount of digits that are in the repeating section is due to this multiplication. However many digits repeat, like here it's just 7, 3. 2 digits, I need 2 decimal shifts. So I multiply by 100. If only 1 digit repeats, we could just multiply by 10. If 3 digits repeat, we could multiply by 1,000 to get 3 zeros. Now, I'm not going to ask you to like regurgitate this proof and like give it back to me, but this, when we get deep in math, you have to like prove that things work. You can't just say, well, yeah, it turns into that over that many nines. This is that proof. This is the definitive. This will always work. I forget if I have more that I wanted to show you. So let's go make sure that we're solid on this. If we go from the fraction into the decimal, right? And we'll review these together because I know this skill is still a bit newer for us. So please go ahead and write down a few of these fractions. We're going to do all of them. Now I'm going to show you the part that most people miss. So I really need you to focus up right here, because this is where most people fall in the trap. 19 over 99, 2 digits over 2 digits of nines tells me I repeat the 1 and the 9. I repeat 2 digits because there's 2 nines, so 0.19 repeated. So go ahead and please make sure you write that down. Same rule at 391 over 999. Right? 3 nines, I need to repeat 3 numbers. Oh, nice, I have 3 numbers. They're the ones that are going to repeat. And same rule, what's this turn into? Yeah, just the 3 repeating, 0.3 with the repetend. Here's where the rules change. And not the rules change, but just what it looks like changes. How many 9s do I have on bottom? 3. How many digits do I have on top right now? 1. I need to make 3. So 0, 0, 1. So what ends up repeating is 0.001. It is in the thousandths place, hence hundredths, thousandths, right? It's the third. You gotta have 3 there because 999. It's the next door neighbor to 1,000, right? Ah, thank you so much. Good catch. That wasn't even me setting it up. I just forgot that. I appreciate that. How many digits repeat here? 3, and we have 3, right? So 0.524 with the repetend, don't forget it. How many digits should repeat here? 3, so we need to add a 0, and we can't put it over here because that would actually change the number. Right? If I put a 0 here, 190 is different than 19. But if I put a 0 here, 019 is the same as 19. Right? That just impacts, I got to remember, I put that 0 after the decimal, then the 19, and all 3 numbers get that repetend. That's what, you can't just put the repetend over the 1 and the 9. You need that 0. Questions here. I restructured how I was going to teach this lesson this year because I'm trying to fill those trap doors so you don't fall in them. Trying to fill those traps. Any questions before we move on? There's always more to do. Okay. Wait time is the thing that is hard for me. It normally takes about 5 seconds of awkwardness for somebody to ask a question. All right, check out these 3 fraction factory tasks. So for those of you that number, which I hope is everybody, but we're on number 23. You don't really need the 2 dash. If it's not possible to fulfill the request, you need to be able to say why. Okay, so check out these 3 orders. I'd like to probably give you 3 minutes and then talk about them. So I'm going to pass out more papers. But check out these 3 requests. If you can't make it happen, why? So you should be like talking with each other.
Yeah. I would like.
I wonder what they would say.
Yeah, we should do that sometimes. So like, I'll
Can I get a McDouble?
Can I get a McDouble terminating
Can I get a McDouble with the side of 49?
Hey, focus on the math. We only have like 4 minutes. Zach and Toby, I need us focusing on the math. We don't have very long left. That's not a check line. I'll clarify that's a cash.
Okay.
So it's okay. That's really fun. We actually want to pay. So you couldn't do it on your own. If you want to come back to the email, right? So all we were doing here is like, okay, so we go from 5 to 15. That would need to be a 3 on 5. So it would also need to be a 3 on 5. Right? To go from that 3 to that 6, it would need to be a 2 on 5. So we put a 2 on 5. But that giant one is just really that multiplication is to do the same on top. Yeah, you're good. And that's why I still gave you a check. I figured it was just an accident. You didn't do that. You are welcome. We figured these out. I don't see much on that paper. So we know the 9's right? Beyond that, I know that actually was the 7's. Yeah, 7's a prime number, right? And then 11 was also a prime number, so I mean that's a good hypothesis. But we haven't explored more than that. So if you're asking like, is 3,000? Check it out. Yeah, we can test it. I'm making laps here. I am shooting to have your tests graded by tomorrow. Get back to you and go over. So I was still getting some people wrapped up in that. My goal is to have you done by tomorrow. I don't give that any till I'm done with all of them. Like, so we go over it 1A and 3B the same day. So I have like 44 tests today. Yeah. It's all good. Last night I was making sure that I had the notes all caught up so that you guys can keep working ahead if you want. Forgot about that. I'll give her a hard time for leaving me later. I just had a brain fart. I'm like, I know she's in this class. I know I saw her this morning. She was.
She left.
All right, so do some random cards here. Mirabelle, what do you think about order 1? Can we do it? How? No? Why not? Yeah, and he said it backwards, but I know what you mean. When you have a number over 99, and even more than that, a rule we were discussing back when Belle and I were chatting, any set of 9s on the bottom, right? 1 9, 2 9s, 3 9s, any number that is all 9s, we've now seen always repeats. Order 2, Olivia, what do you think about order 2? You didn't get there yet? Totally fine. Anyone did get? Zach, what do you want to say?
Possible.
It is possible. How?
Because you can multiply 0.08 times 3,000 and then do the same with 125.
So if we look at the number they gave you to start, how do we read that appropriately?
208,000.
Yeah, 208 thousandths. They asked for a denominator of 3,000. Can we do this? Yeah, exactly what Zach is saying. We just multiply by 3. So the numerator multiplied by 3, okay, 600, 8, 16, 20, 624, I think. And we'll get a check on that. Is that good? Good, thank you very much. So order 2 we can do. We can fulfill that order. Savannah, what about order 3? Can you do it on the fly?
Sure. That's impossible because it is repeated.
It is repeating.
Oh, I'm a fraction.
Yeah.
So, that would be 44 over 99.
Ooh, yeah, except it's 43. They asked about 44 up here. So yeah, 43, because 2 digits repeat. Absolutely right, Savannah. It is over 99. Any final questions before you're out for today? However many digits repeat, it's that many 9s, right? All right, thank you guys very much. Have a wonderful day.
Why is it
Why is what? I don't know. You could ask Braylon Vio. I can't ever say his last name right. Probably Natalie. They come in here and draw in the morning. They are 8th graders. If you do not know them, they are cool people.